All right, so we talked a little bit about the factoring, and we talked a little bit about the different things that you should be. Now, I haven't forgot about the homework questions. We'll probably go over homework questions next week. I want everybody to start sending them because I only got like one or two, and I know dang well people have more than one or two questions. So I'm going to give everybody a chance to catch up on the homework, and that's the online class too. The online class needs to send their questions in, and starting Monday, we'll go over questions. But let me go ahead. I've already started to. Yes. Yeah. All right. We've already talked about set builder notation. We've already talked about interval notation, but I'll leave that on the screen just for a few seconds. That way you can pause it when you're watching the video, and you can set builder notation. Some teachers use it. I use interval notation, so make sure that you make a note about interval notation. Remember that brackets mean inclusion, parentheses means non-inclusive. Here's examples of using the brackets and using the parentheses. Brackets means inclusion. That means you can use the number. Since you don't know what infinity is, you never put brackets on infinity. Never. That is a no-no. Okay? All real numbers can be written. You need to highlight this down here. All real numbers can be written as negative infinity to positive infinity. That is the same thing. The only time you can be marked wrong with that is when the question says, please put an R for all real numbers. And there you just need to read the directions. Remember, a union is when things do not overlap. And an intersection is when they what? Overlap. Okay? So a union is when things do not overlap. Do people get married and not have anything in common? Yes.
Yes.
Okay? That's a union. All right? People get married when they don't have anything in common. But as far as the intersection of two roads, that's the asphalt of both roads. So they have something in common. There's an overlap. Intersection of two roads, union, people get married even though they don't have anything in common. Remember it that way. Interval notation. This is parenthesis, -3, comma, 5, bracket. This, negative infinity, comma, 3, bracket. Negative infinity has a parenthesis on it. Here, 3 with a parenthesis, comma, infinity, parenthesis. And there's the answers. We've already covered this, and I'm just going over, I'm just trying to make sure I cover everything. Relation, domain, and range. We've covered domain and range. I really care about domain and range on a graph. I don't give a lot of these questions right here, so make a note that you need to go over this question as a homework question or a standardized test question, but I usually give domain and range, I give them on graphs. So when you see a graph, domain and range, that's a test question. There's, well, you can graph it. Let me go back. Okay, there's the 3. Now remember, when it's points, you have to list -1, domain, -1, -2, 5. I'm sorry, I'm fast backwards. -2, 1, and 3. That's your domain. Range, -1, 2, and 5. Now, why do I start from the bottom? Well, I'm consistent, all right? And when you're in math, you need to be consistent. Let me turn on the whiteboard. I didn't turn on the whiteboard. I got so many things I have to turn on. I ought to be like the other teachers and just kind of, no, I ain't gonna say nothing. Be good, be nice. Settle down, Pendleton. One person interacts up there. Get one person. The other one's tit on a bull. Got one person. Thank you, one person that interacts. All right. Let me go back here. There we go. And go back there. And open this up. And there we go. If I was to... Is that the one we were on? No, that's not the one we were on.
Those are the points.
We were on the graph, or we were doing... What were we doing? Hold on. It's not my fault. It's the Russians' fault. Okay. I thought we were on that one. There we go. And what was I saying? Okay. If I give you a graph on the... This is what I'll do. I usually don't give these, but I usually give one that has the line on it. That's what I usually do. The reason I do those is because those are the ones you're mostly going to see in calculus. That's the ones you're mostly going to see in trig. You're not going to see dot, dot, dot. You're not going to see that. So I try to not do those. Just remember, when you have dot, 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 you need to list the domain in terms of dot, dot, dot. Just remember that. When it's dot, 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 you do the domain in dot, dot, dot. When it's a line, you can go from this point right here to this point and not have to do the dot, dot, dot. Okay? I just need to make sure y'all understand that because some people get it wrong on a test. Not a very difficult. Okay, here's an example of one that would be on a test. The graph of the line or curve in the XY plane represents blah, blah, blah. And there is the function. And I'm going to put a line because it says line or curve. And the domain is going to be from -2 to what? +2. What's the range? -4 to 4. Now they put arrows on the end of it, which, okay, all ordered pairs, write that down, all ordered pairs, so it's not stopping at -2 and +2. All ordered pairs gives you the right to put what on the end of it?
Arrows.
Arrows. All ordered pairs. I'm not usually that vague when it comes to, and try to draw with a mouse. See how you can do it. Sucks. Okay, all ordered pairs means basically I'm going to put arrows on the end. So my domain and range have quickly gone to negative to what? Positive infinity for both, which means all real numbers. Okay, here's those dat blame things that drive people crazy. All right, remember, you can't have, for a function, you can't have two what? You can't have 1x with two what?
Y's.
2 y's. So this is a function. All right? You can't have 1x going to 2 y's. This is not a function. It's not a function because vertical line test dictates it crosses 2 times. Range is your y values, domain is your x values. We've already talked about this. All real numbers. It's got arrows on the end. -2.75 to infinity is your range. Domain is all real numbers. Okay, -3. That's wrong. It's not -3. Oh well, it's the Russians. They hacked in and moved that line. Okay, is this a function? No, it is not a function. Is this a calculator drill? Yeah. So make sure you can do the calculator drill. The domain would be -3 to what? 3. The range would be -1 to 1. I don't care about what it looks like on your graph. You can play with your graph however you want to, whether it's zoom box or whether it's window or whether, however you want to. I don't care about that. Okay? We've already talked about that. We talked about independent and dependent. Give the domain and range of each relation. That's points. So you're going to give from 1, 3. The domain is 1, 3, 5, 7, 9. Range is what? 2, 4, 6, 8, 10. Exactly. That's good for your knowledge, but I do not put those on the test. Domain, 1, 2. Does this, let's look at it. For each x, do I have 2 y's? Let's see. No. 1, 1, 1, 2, 1, 3. Those are 3 separate points, and 2, 4. So this is a function. Range is 1, 2, 3, 4. -4, 2. This is a, what is this? This is a horizontal what? Horizontal line, Hubert. That's right, class. Because y is equal to a number. It's a horizontal line. This is y is equal is y minus 2. That's our. We're gonna get to the horizontal shifts in just a minute. I'm gonna wait before we go over that one. Vertical line test. If the vertical line passes one time, then that means it's a function. Yes, no. So you need to put this in your notes. Again, this is a review of what we've done, talked about. A parabola, a straight line, a x to the third, absolute value, and we're going to get to the parent graphs. Did we do the parent graphs in here?
I don't think we talked about it.
Okay, we hadn't done that yet. I don't think we've done any graphing really. So we're going to get to all this in just a minute. A function is correspondent, which blah, 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 blah. Okay, I'm going to go ahead and go into what we're going to go into. There's the thing that I can't stand these things. So that's a function because 1x goes to what? 1y. That's a function. That's a function. That's a function. Plug and chug. Plug and chug. Okay. All right. We're going over something else. I'm not going to do this. That's taking up too much class time. Let's go to the whiteboard. And let's talk about the parent graphs. Now what I want everybody to do is get out a sheet of paper, straight edge, and if you don't have a straight edge, I want you to take a straight line somehow, turn it landscape, and I want you to draw the following. Now we are going over a lot of Chapter 2 and Chapter 3. Okay, I kind of combine it, especially for the online class. If you watch this video, I do combine Chapters 2 and 3 kind of together, which is Unit 1 and Unit 2, so y'all just bear with me. I want you to draw 8 sections, like so. I want you to draw a graph in each section. I'll show you in just a second. This is called your parent graphs or graph family of graphs, whatever you want to call it. All right, the first graph that we're going to draw is going to be f of x is equal to x to the first power. Now, what is the characteristics of x being raised to the first power? Might tell me what all the graphs will look like that x is raised to the first power.
It'll just be that number.
Huh?
It'll just be that number, whatever X is.
Yeah, well, what will the graph look like? That's what I'm asking.
A straight line.
A straight line, meaning that you have a linear function. Meaning a what? Straight line. So anytime you have a function when x is to the first power, that means that you have a straight line. Okay, what about f of x is equal to x squared? What does any quadratic look like? Parabola. That's what I called it in my Math 110 class at Tri-County Tech. I went into Oconee Hall, and I remember from 102, I said, that's a parabola. And Dr. Gabati, I had him for a week. I dropped him after the first 3 days. He goes, Mr. McClure, I do not understand what you are saying. There's a parabola. It's a parabola. Okay? F of x is equal to x to the third. F of x is equal to x to the fourth. This is called a quartic. It's also f of x is equal to x to the even power, where this is f of x is equal to x to the what? Odd power. Now that plays into the part, take a highlighter, and when it's odd, you're going to have this kind of ending behavior. When it's even, you're going to have what kind of ending behavior? Well, if I can work that gum forward, you're going to have this kind of ending behavior, meaning it's a parabola. But the higher your exponent, the more what? The more squared off the bottom is going to be. Okay? So if I have an x to the 12th power, I know that my parabola is going to be very... What happened to my parabola over here? It just disappeared. Did I not draw it?
You did.
I suck. There. On an x squared parabola, it's almost like a V. Okay? And the higher up you go, the more squared off your bottom is going to be. Okay? The more, whatever you want to call it. Okay, so with an odd function, you're going to be having the ending behavior of one opposite directions. With an even function, you're going to go in the same direction, but the only effect is the higher the exponent, the more squared off the u is going to be, or the parabola is going to be. Next, f of x is equal to the square root of x. I used to call it a swoosh, but I'm not going to call it a swoosh because to hell with Nike, I'm not going to use that word again. Okay? So it's a line that goes off to the right. Okay? I don't even know who that is. Square root of x. It's a line that goes off to the right. Why does it go off to the right?
Because you can't have negative square root.
Because you can't have a negative square root. Okay? F of x is equal to the absolute value of x. This is easy to remember. Absolute value, absolute vodka, especially for you alcoholics. All right? Absolute value, absolute vodka. Vodka and value start with a what?
V.
A V. So it looks like a V.
E.
Somebody's going to go to my department head. He called me an alcoholic. Didn't call nobody alcoholic. I said, for you alcoholics, you want to raise your hand and say, I'm an alcoholic. You're not only an alcoholic, but you're a DA for raising your hand. All right? God, get a sense of humor. f of x is equal to 1 over x, half a volcano. What do you mean, half a volcano? Well, look at f of x is equal to 1 over x squared. If 1 over x is half a volcano, what's 1 over x squared? It looks like a volcano. Now, I show you these because these are your parent graphs. These are your graphs that you're going to compare everything to. What do you mean? Well, let's say, I don't know what the most popular car is right now, so I'm just going to use the Mustang. All right? When you buy a Mustang, if I say, I went out and bought me a brand new Mustang, does that tell you anything? No, not really. But what if I told you I bought the Mustang XL, or I don't know what they call the Mustang, the different models, okay? But, or GT, or GTO, or GTS, or whatever. They got numbers or letters after it. Let's just use a truck. That's the only thing I know about, a truck. All right, let's say I go out and buy a brand new F350, okay? I could buy the F350, I could buy the XL, I can buy the XLT, or I can buy the Eddie Bauer, Harley Davidson, whatever. Okay, I can buy the different models, but all of them goes back to the F350. All right, now I can have an F350 with just an engine in it, and a transmission, air conditioner, and FM/AM radio. Okay, that's basic model. These are your basic models. All right, everything that we compare to from here on out is going to be compared to these 8 graphs. Okay, these are your basic models. If I add air, if I add heated seats, if I add a souped up engine with a torqued up transmission, then I'm adding to the basic model. All right, so how do we do that? Well, we're going to see in the next few days how we do that with the equation that's given. All right. For instance, I'm just going to move into this a little bit so you can see where I'm going with this. We're going to learn it, but I just want you to see what we're doing. If I give you f of x, and you don't have to write this down because we're going to get into it. You can if you want to. If I give you f of x is equal to x squared. Well, I'll tell you what. Go ahead and get another sheet of paper. And here's your sheet of paper right here. This is your sheet of paper over here. I want you to draw a big A graph like this. I want you to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want you to get your highlighters out. I want you to get your colored pencils or your colored pens because we're going to draw like 3 or 4 graphs on this one graph. And I tell you, I want you to plot points on f of x is equal to x squared. Well, you know how to do that because you always do the little -2, -1, 0, 1, and 2. And that's going to be a 4, a 1, a 0, a 4, a 1, sorry, and a 4. I go over here and I plot those points. -2, +4, 1, 2, 3, 4, 1, 1. 0, 0, 1, 1, and 2, 4. And I told you, that's the basic what? That's the basic model, Hubert. That's the parent graph. F of x is equal to x squared. That's your basic model. I want you to draw that in pencil or black because that's your basic model. We're going to compare everything we do with that function. Okay, now I'm going to take my handy-dandy cursor. And it probably won't work, but I'm going to try it anyway. Nope. Now, I want you to go over here, and I'm going to move that. I'm going to just redraw it because I want to put f of x is equal to x squared, and I'll just redo it. -2, -1, 0, 1, 2. 4, 1, 0, 1, 4. Now I want you to do it in a red color. It means red, pink, orange, anything that's got a little bit of red if you got different color. I told you to get highlighters, colored pencils, or pens. Okay? I want you to do f of x is equal to 2x squared. -2, -1, 0, 1, and 2. All right, draw that one. And I want you to draw it on the graph with this one. And I want you to, you can use a pencil to plot your points, but then color it with a highlighter or something to distinguish it from the basic points. And Dog's gonna go down to Columbia this weekend. I don't think it's gonna be pretty. What do y'all think? I think it's gonna be a massacre.
Well, they already talking. So
What?
the tight end for South Carolina saying that they can beat us like 5 different ways.
South Carolina? I don't think I would publicize. We'll have to see what Clemson does, because you don't know what Clemson's going to do until they play a first-rate opponent. So they're going to be playing Jimbo. I think they're going to have their hands full. I'm glad Jimbo is out of Florida State. I'm glad. You see what happens when a good coach leaves. Florida State got their butt handed to them the other night.
Either Miami sucks or LSU's good. One or two.
Well, that means all children's conference is one team,
Yeah.
and that's Clemson. I'm sorry, Clemson. I don't want to come across as a racist Southerner, so I have to say Clemson. Some of the students are going like, "What's he talking about?"
Yeah,
Need to watch daggum ESPN. They don't say Clemson. They don't say Clemson, and they don't say Clemson. They say Clemson, because they don't want to be associated with us common folk down here. We say Clemson.
Penn State that lost to Appalachian State.
Appalachian State, you never know what they're going to do. They'll play Michigan and beat Michigan with a field goal, and then they'll do Penn State like that. But I really don't see anybody in the all children's conference this year. Maybe Clemson, but you won't see what they're going to do until they play a ranked opponent.
Miami, third. Florida and South Carolina.
Wouldn't you hate to be South Carolina though? They're second. You play a cupcake bowl, and then you play the number 3 team in the nation. That'd be rough. Who's Alabama play? Another cupcake bowl this week?
Yep.
What do they play? Spartanburg High School? All of them played cupcake schools this week. That was Cupcake Bowl this weekend. South Carolina played Aiken High School, and Clemson played. We'll give Clemson a little bit. They played Burns High School. Okay, they played a little bit better team. And then who did Georgia play? Georgia played Austin High School. I can't stand the first week of college football. I don't even watch it. All right, so we take our red pen, and what is 2 squared? 4. 4 times 2 is 8. 1 or 2, 0, and that's going to be 2 and 8. So you plot those points. -2. And what? -2 and 8. Well, that's 4, 5, 6, 7, 8. 1 and 2. 1 and 2. What happened? It's getting what?
Narrow.
Okay, more narrow than the basic model. Write that down. And highlight that 2. Highlight this 2 right here. And put down at the bottom, more narrow. Well, you can put skinnier, you can put more narrow, but basically we're stretching Think of a balloon. We're stretching along the y-axis, and what are we doing on the x-axis? Compressing along the x-axis. Now, 25-cent word for that is what? Skinny. Think of a balloon. If I pull a balloon from here to here and go up there and there, what's going to happen to my balloon? It's going to get what? It's going to get skinny. But I can also do that same thing by compressing along the what? The x-axis. Will that do the same thing as stretching along the y-axis? Yes, it's the same thing. The ultimate is it's going to get skinnier. Now you need to know that because the homework and some standardized tests will ask you, what are you doing? And they'll want you to, is it compressing along the x-axis and or it's stretching along the what? Y-axis. All right, let's do a narrative. Let's do this one in blue. Let's put a blue tint to it, something opposite of red. So f of x is equal to 1/2 x squared. And being the good teacher that I am, I'm going to tell you to use multiples of the what? Denominator, because it's a what? A fraction. Any good teacher would tell you to do that. If you haven't been taught that, you had a crappy teacher. Whenever you have a fraction, you always use multiples of the what? Denominator. Now again, we're kind of combining a little bit of Unit 1 and a little bit of Unit 2. So I just be patient because I'm going to get into the mechanics of this as soon as we get there. Okay, I'm just trying to show you where we're going. So what's -4 squared? 16 divided by 2? 8. 2 squared, 4 divided by 2 is 2. And I'll do this one for you. 0 times anything is 0. There we go. So -4 and +8. -4, 1, 2, 3, 4, +8. 2, 4. 0, 0, 2, 4, and 4, 8. What happened? It's getting wider. So we're going to highlight that 1/2 right there. And now we're going to put down here, it's going to get wider. Well, 25-cent word for wider, or hold your pinky up when you say it, is that what? You are stretching along the, I don't even know how to spell stretching. You're stretching along the x-axis. And you're compressing along the what? Along the y-axis. What am I doing to that blue line? I'm going which way? Out. So I'm stretching along the x-axis, or you could say I'm what? Compressing along the what? What does it do to that balloon if I compress this way? It's going to make it go out. So it depends on where you put your vise, where you compress. If you compress along the y-axis, it's going to get wider. If you compress along the x-axis, it's going to get skinnier. And what tells you that? Up here. Let's go to our red and put up top. If A is above 1, you have what? You have a skinnier graph than the parent graph. Blue. If A is between 0 and 1, you have a what? A wider function. Does that mean with parabolas? Does that mean with absolute value? Does that mean with the 1 over x? Does that mean with 1 over x squared? Yes. It means the same thing. Sine, cosine, tangent? Yes. If I have a 4 in front of a tangent, what does that mean? that means it's going to be skinnier than the original model of tangent. If I have a 1/2 in front of a cosine, does that mean it's going to be skinnier or wider? It's going to be wider than the regular what I say, sine or cosine? Cosine. Okay? So, whatever I put those numbers in front of, if I put it in front of the x squared or the absolute value of x, or if I put it in front of cosine of x, it's going to make it either wider than the original or it's going to make it skinnier. Now, what I don't understand. What if it's negative? Let's do that. We'll do that in dang old Verde. F of x, we'll use the negative 2x squared. Well, we don't even have to plot that because why? What does negative tell you in math and science? Well, that was a mistake. What does the negative tell you in math and science?
It's the opposite, or it goes down.
I'm looking for a D word.
Oh.
D, I, R, E, C, direction. Y'all are so gifted. Y'all know, I just ask y'all questions and y'all just tell me right off the bat. Direction. In math and science, even accounting. What do you mean accounting? What does negative tell you in accounting? You in the hole. You below your balance. What does positive tell you in accounting? You got money in the bank. Tells you direction above the number of 0, below the amount of 0, whatever the case may be. In this case, the negative tells you it's going in the opposite direction of the red. So I can just copy the red one and just go which way?
Down.
Down. Open and downward. So, what the heck are you saying, Hubert? Well, let's go to another screen. Keep this screen for right now. Keep it. We're going to come back to this. I'm going to go up here, my handy-dandy virtual board. What is the general form of a quadratic equation? F of x is equal to ax squared plus bx plus c. Everybody remember that from 102? Now you know what A tells us. So highlight that A right there, and it tells us orientation and what? Starts with a B. I, R.
Direction.
Thank you. Appreciate that one person in Pendleton. Orientation and direction. If A is greater than 1, then you have a what? A skinny representation compared to the basic. If A is between 0 and 1, you have a wider representation of the basic. What if A is equal to 3/2 x squared? Or what if A is equal to 3/2? Wide or skinny?
Skinny.
You weren't supposed to get that right. You're supposed to get it wrong like everybody else. It would be skinny. Why? Uh-oh. What happened to Pendleton Oconee? Y'all there? Did y'all just see that?
Yeah.
That was weird.
Y'all know what it is.
The
Good
Russian.
job. Russians. The Russians are trying to persuade y'all to fail this class. They're gonna come get you. They're gonna throw you in a van. They're gonna beat you up and make you fail this class. All right. So, how do you know which fractions? Well, remember your wrench sizes. What are your wrench sizes? 7/16, 1/2. What's the next one? 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, 15/16. What are all those wrench sizes? What are all those fractions? Are they proper or improper?
Proper.
Proper. If you have a proper fraction, it's going to be wide. Write that down. Proper. Put proper under 0 between A. A between 0 and 1, put proper fraction. If it's a proper fraction, that means it's going to be Y.
Sir,
Sir,
I can't see your screen.
Sir,
Neither can we.
my name is Hubert, okay? That's a weird name, but my name is Hubert. Then I told you the Russians were going to do this.
Yeah, I can't see.
Hold on a minute. I'm going to take you out and bring you back in, okay? Well, let me try this first. I'm going to hit the present screen again and see if it comes up, okay? Why is Pendleton, why is the whiteboard not working?
There it goes. There it is.
Pendleton, the white screen, the whiteboard's supposed to be on. These teachers, they get me. They have this, they don't even use what they got. Okay. My one person that interacts with me is Pendleton. Would you get the remote control, the white remote control, and turn on the projector, please? It's like pulling hen's teeth to get these teachers to use technology. And what we're called, Tri-County what? Technical college. And we have faculty that walk around like T-Rexes. Okay, the projector over there on the whiteboard, is it coming on?
It is on. It's just really hard to see it from, the
Okay,
light.
yeah,
really
I see it
bright.
now. Well, then turn the light off that goes over it. You should have two switches back there. Go back there and look. Is there two switches?
No, sir, just the one.
Oh, then y'all be sitting in the dark, so you can't. All right, now make sure it's maximized. Make sure it's maximized
there it
to
goes.
where you can see it over there on the white screen, not on the TV monitor, on the white screen.
It is. It's on the dry erase board over there.
Okay, so it's maximized. That doesn't look like it's maximized. There should be a little thing up there that's got two arrows going in opposite directions. I'm just asking. I don't know if it's...
It's already on full screen.
Okay.
It's on the other whiteboard. I don't think you can see it from there.
Yeah,
It's not this
I can
one.
see both of them.
Oh, okay.
Okay,
Well,
I
it's
just want
on-
to make sure, to have the technology in the classroom and not use it is, but like I say, we have T-Rexes on campus. All right, we got people still asking for what is it called, overhead projectors?
Mm-hmm.
Anyway, so if it's proper, then it's going to be wide. Proper fraction. Okay, now, Hubert, where is this going? Okay, now, this is a parabola. All right, what if I give you this? F of x is equal to 3 absolute value of x plus 6. Then you would automatically know, you'd say, okay, my parent graph says that the absolute value looks like that, but 3 tells me that it's going to be what? Skinny. It's going to be skinny. What about this? If I give you f of x is equal to 3x to the third. Well, you know x to the third looks, x to the third looks like this. So a 3x to the third is going to be what? It's going to be skinnier. Okay? I don't care if you're in trig next semester. If I put a 3 cosine, it means it's going to be compressed and stretched along the y-axis. If I give you a 1/2 cosine, it's going to be stretched along the x-axis and compressed along the y-axis. It's going to be wider. And that's what you need to see right here. Okay? You need to see that A tells you direction and what? Orientation, Hubert. Yes, right there in front of y'all. Thank you. Appreciate the interaction. What if I put a negative right here? Same as the blue line, only it's what? One opposite direction. So the A in front of your main leading term, why is this the leading term? Because it has the leading what? Exponent, index. It's called an index. Then I know that that is a orientation and direction indicator. What else is there? What about the B and the C? Well, we're going to get to that with quadratics. But I'm going to show you a real basic, because really this book gets the cart before the horse. All right? This book goes into vertical and horizontal shifts before it goes into quadratics, and I don't agree with that. I think you should show the quadratic transition, then show the vertical and horizontal shifts. That's why I kind of do Unit 1 and Unit 2 together. All right? So let me show you what I'm talking about. And I'm going to go with the book here because I really don't like it. But f of x is equal to a times x plus h, quantity squared, plus k. F of x is equal to a times absolute value of x plus h plus k. F of x is equal to a times the square root of x plus h plus k. And I'm just going to do one more. F of x is equal to a times x plus h, quantity cubed, plus k. Now, what does everybody notice about these 4 examples that I put on the board? Tell me what you notice. Anything.
Got the same variable.
They got the same variables in the same what? Places. Okay, that's one thing. What else? What else do you notice? They're all versions of the what graphs? Parent graphs. So now you know what each one of them looks like because one's got a 2, one's got an absolute value, the other one's got a square root, and the other one's got a cube root, or a cube. So you know what they look like. So you say, okay, this one is a parabola. And this is what you should be thinking when you see these. This, absolute value, absolute vodka, looks like that. This one is the line that goes to the right. The Hebrew won't say the other word. This one is a cube, so it looks like that. That's what you should be saying in your head because you know the parent graphs. How many of you have seen the parent graphs before? Okay, good. That means your 102 teacher or your Algebra 2 teacher taught you. Good. All right. Now, what about the H and the K? Well, let's go ahead and say what that is. The H on all of these, anybody want to tell me from their review of 102 or Algebra 2, what is the H? Nobody remembers? Horizontal shift. Write that down. H is equal to the horizontal shift. This is the only time in mathematics where negative means right and a positive means left. Now, I believe in a very democratic society. All right? I do not believe that the minority rules. I believe the majority rules. So, I'm going to ask y'all a question. Do y'all want me to go through the explanation of why that is true? Yes or no?
Yeah.
Really? Okay, I'll go through it real quickly. Did everybody see this plus right here? In order to get a plus right there, I would have to have a negative. So that's why a plus is really a negative because it's negative. Actually, it's supposed to be it's supposed to be x minus h is what it's supposed to be. but a lot of teachers write it as x plus h, and then they just say go with the opposite. But if I wrote x minus h, then if it was to be a minus h, that would be a plus h. Therefore, minus h would be to the left. You see why I don't explain it to you? It's very redundant and confusing. So that's why I don't. So just remember, it's always the opposite. Write that down. H, the negative means right, the positive means left. Well, if A is your orientation and direction, and H is your horizontal shift, then what do you think K is?
Vertical.
Y'all amaze me. I ain't kidding. Y'all really do. Is it just the Anderson campus or what? Are y'all just exceptionally smart, or it's the vertical shift? K is your vertical shift. And the vertical shift is normal. The vertical shift is normal. That means positive goes what? And negative goes down. So now you know several things when you look at a problem. Let me highlight this. There we go. Then I'll highlight this in per day. Y'all are impressed, aren't you? I know dang old Spanish, dang old per day.
Hanging out with
Okay.
Corey too much.
Huh?
Hanging out with Corey too
I
much.
know. I've been actually. The Mexican restaurants are very good about refreshments.
Yes.
They're very good about that. And that's what attracts me to the Mexican restaurants.
And the freaking chips and sauce.
I can hear it right now. Department head. He's saying he's an alcoholic. Yeah, I'm an alcoholic. My name is Hubert, and I'm an alcoholic.
First step.
Yep, it is. Somebody's gonna say I'm making fun of them. I swear, it's just like you can't win. It's like sense of humor Nazis. They're born like every day, and they don't have no sense of humor, and they, sit at home and watch ETV all day or something. I don't know what they do. They watch that guy with the afro that paints. What's his name? Bob or something.
Bob Ross.
What's his name?
Bob Ross.
Bob Ross, yeah. I like artists and everything, and I like art. I studied art and architecture a good bit at Clemson, but that guy's strange.
Little trees.
Yeah, happy little trees. I bet he's got like an axe in his dadgum trunk of his car or something. I bet he's just
dead
strange. Huh?
He's dead now.
Is he?
Mhm.
They still playing him?
Yeah.
Yeah.
How long has he been dead?
I don't know, like 10 years.
I'm watching this guy on TV thinking he is actually normal, like living. And he's been dead for 10 years?
Something like that, yeah.
Yeah.
That's strange. All right, so orientation, A is orientation. So now we've got A, H, and K. Now, all right, now I'm going to show you where I'm heading with this. All right, this is Unit 2, Unit 1. This is what you're learning in Unit 1. Vertical, horizontal shifts. Yeah, just come on in whenever. How was breakfast? Was it good? Did you go to IHOP to have a nice little spread?
I did. I
Good.
bought you a biscuit.
Good. I'm glad you had a nice time. Just come to class whenever you want to. All right. So here we go. F of x is equal to x squared plus 4x minus 7. Okay. Now you don't have to write this down as you just put for your information. In other words, this is where Unit 2 is going. Okay, this is where I'm going in Unit 2, and I think the more I expose you to completing the square, the better. So we're going to write out here complete the square. Because right now, the only thing you can tell me about this is you can say that A is equal to 1 and it has a y-intercept of -7. That's all you can tell me. But when you get through using completing the square, you're going to be able to tell me the vertex and the x-intercepts, and then you're going to be able to plot the graph. Okay? So how do you do that? Well, I'm going to write down the numbers because I spend Unit 1 and Unit 2 completing the square wherever I can. Therefore, when you get to the end of Unit 2, you will all be what? Smart about what? Completing the what? Square. So, for those of you that are a little bit confused about the way I'm doing this, just chill, and especially those people online that are taking my Math 110 online, I do it because at the end of Unit 2, you'll be very, very aware of Unit 2 material. Okay? So, first thing, set equal to 0. 2, move C. 3, add blanks. 4. 4 is important. I'm going to put 4b divided by 2 and square it. I'm going to highlight that in verde. Because if you don't do number 4, you might as well just not even do the problem, because number 4 is the key that unlocks the whole thing on complete the square. All right, so if you don't do number 4, you might as well just leave it blank. And 5, if you do completing the square, it will leave shortcut number 1 or 2 on the left-hand side. 6, find your vertex, and I'll show you how to do that. And 7, solve for x. Now on a scale from 1 to 10, this one's about a 1. We're going to go all the way through 10. I'm going to give you each difficulty level.
ST, what is it?
Shortcut number 1 or number 2? Pay attention, please, or I'll throw you out of class. Oh well, forget it. I'll just erase this. So the first thing I'm going to do is set equal to 0. Well, how do I set equal to 0? What's the only thing you can put 0 in for? F of x. Well, that's y. Yeah, I'm putting in 0 for y. If I plug in 0 for y, what am I getting?
0.
Your x what?
Intercept.
Intercepts. Write that down. Since I'm plugging in 0 for f of x, which is y, if you plug in 0 for y, you get the x-intercept. If you plug in 0 for x, you get the what?
Y.
Y-intercept. So go ahead and write down, what is our y-intercept? You already know that from the beginning of the problem. -7, Hubert. That's right, class. Thank you for the interaction. Why is it -7? Because if you plug in 0 for x, what do you get? 0 squared plus 0 minus 7. And what does that give you, class? -7. Thank you, class. So the y-intercept is -7. Thank you for the interaction. Y'all wonder why class is boring. Class is boring not because of the teacher, but because of the what? The class. No, no. Quiet as a mouse. I want everybody to be quiet. Maybe if I go that route, what do you think? If I start being a butthole, maybe everybody will start talking then. Okay, I got a little bit of that. I got one person. That one person. Thank God for that one person up there in Pendleton. She's going to make an A. Okay, the rest of them are going to fail. All right, so now I've done number 1. What about number 2? What am I going to do? I love number 2. Because I say move C and students go, where are you going to move to? Well, where is it? It's on the left. If it's on the left, where's the only place I can move it?
Right.
It's a miracle. X squared plus 4x plus blank is equal to 7 plus blank. And I also added my blank. So number 2 and 3, you can do at the same time. Now we're going to go through about 10 or 15 of these. And by the time we get to 5 and 6, you'll be like, okay, I know how to do this. You should know how to do it if you come out of Algebra 2 or Math 102. But you know why some people don't? Because half the time teachers don't know how to explain it, and they tell you to do the quadratic formula, which you don't do unless you have decimals in here. Quadratic formula is to use with decimals. Bet you didn't know that, did you? No, they just told us to use our calculator. Yep, exactly. Number 4. What's B?
4.
Divided by 2.
2.
2 squared is?
4.
So I'm going to add 4 there and there. Now you need to write that down in your notes so you don't forget it, and you need to highlight it. 4 divided by 2 and squared. A lot of people say, well, Hubert, what if it's a negative 4? Well, what's negative 4 divided by 2? Negative 2. And what's negative 2 squared?
4.
Does it matter whether it's positive or negative? No, it doesn't. So you don't have to worry about that. So 4, which is B, divided by 2 and squared. And for those of you that walked in after eating breakfast all morning, f of x is equal to ax squared plus bx plus c. B is 4. Figure that might help some of y'all.
Thank you.
Yeah, you're welcome. Next, after you do that, what's on the left-hand side? Shortcut number, in this case, number 1, because it's got plus symbols. That one right here is plus, so that's shortcut number 1. Shortcut number 1 gives us x plus 2, quantity squared, is equal to 11. Question, gripe, complaint. Now, there's 2 directions you go here. I'm going to draw 2 arrows. One's going to go to the left, and one's going to go to the right. The one to the left is going to say vertex. One to the right is going to say solve for x. Now I'm going to go to the next board. I don't want to try to make it smaller because it probably won't work. I'll try it, but it's not going to work because I'm only going to grab half of it. Well, it doesn't do that. Oh, no, it only grabbed, no, it grabbed the whole thing. Except it didn't grab the numbers over there. There's no consistency whatsoever with this. No consistency. Damn Russians. So I'm going to go ahead and I'm going to take this. X plus 2 squared is equal to 11. And I'm going to x plus 2 squared is equal to 11. And y'all keep writing on your regular notebook paper. I just ran out of room. Okay, and I'm going to go over here and I'm going to say vertex. And I'm going to put opposite of both numbers. Opposite of both numbers. There's only 2 numbers up there. So don't reinvent the wheel. And over here, solve for x. So I'm going to rewrite the equation down here. And over here, I'm going to take the opposite of my 2 numbers. What's my 2 numbers?
11.
2 and 11. So what's the opposite of 2?
Negative 2.
What's the opposite of positive 11? So there's your vertex. It's always the opposite. Don't reinvent the wheel. It's always the opposite. Now, I will tell you for your information that there are sometimes directions to tell you to put in general form or intercept form. And if they ask you to do that, you put a f of x in front of the equation and you bring the 11 back over, and it's x plus 2 quantity squared minus 11. Now you need to make a note of that because sometimes you're going to see that on your homework or test, and they're going to say put it in general form or put it in intercept form, and that's what you do. You bring the 11 back over, and then you put an f of x out in front of it. I just tell students to find the vertex, and there's the vertex right here. No coughing or sneezing in class. Okay, so there's your vertex. Next, got to take the square root of both sides. X plus 2 is equal to, okay, square root of 11. Square root of 9 is 3. The square root of 16 is 4. Square root of something is 3.5. Well, what's 9 to 16 is what? 9 to 16 is 7. Half of 7 is 3.5. So that's 12.5. And 3.5 is 1.75. So that'd be 10.75 is equal to 3.25. So I'm going to say 3.3. So x is equal to positive or negative 3.3 minus 2. And that's going to give me, what's $3.30 minus $2? It's a miracle. $1.33. $1.03. That's good. 1.3. And if you owe somebody $3.30 and you owe somebody $2, what do you owe them? You owe them $5 and what? 30 cents. There's your two x-intercepts. So I want you to plot all 4 of those points. You got 4 points to plot: the y-intercept, the vertex, and x-intercept. I'll be right back. Sorry about that. That bourbon I put in that water bottle is going through me. Somebody will go tell my department head that I'm drinking in class now. All right, so here we go. We got a horizontal, what was the 7, negative 7? Somebody tell me what the y-intercept was.
-7.
5, 6, 7. We know the vertex is -2, -7, 8, 9, 10, 11. We know that the 1.3, 1, 2, 1.3 be right in there. And -5, 1, 2, 3, 4, 5.3. So does everything line up? Yep. Now let's go back and look. Okay, what kind of parabola, let me go to A. What kind of parabola do we have? What's that number in front of that parenthesis? It's a 1. So what does that mean? It's your basic model, right? It's the one, this is like your basic model that we showed on a pair of graphs a while ago. All right, now let's go to the vertical shift. What's the vertical shift? Yellow? I can't remember. Positive 2. So that means left, how many? 2 places. 1, 2. Yep. And then the vertical shift, I think I made it per day. The vertical shift is what? Negative 11. So there's your vertical shift. Horizontal shift is always the opposite. Really? There's your vertical shift and horizontal shift. Now, you're going to have to do this with absolute value. No. Absolute value, your cube function, your square root function, they will always be given to you in the form a times x plus h, quantity whatever, plus k. They will always be given to you. But with the quadratics, they want you to be able to change it. So unit 1 is given in this function what is the vertical and horizontal shifts and orientation. In unit 2, they want you to convert from a quadratic to this form right here. They want you to change that quadratic to that form so you can tell me this information right here. The vertical, the horizontal shift, and all that good stuff. So that's what you're going to be doing in unit 2. All right? But first, we need to get down the vertical and horizontal shifts, and that's what we do in unit 1. So, in unit 1, I'm going to give you a bunch of problems here. I'm going to give you about 3 problems, and I want you to graph it in your notes. So you might want to have one. You might want to divide your paper into 4 squares. Okay, you're going to put 4 graphs. We're going to do 4 of them. All right. First one, and I'm going to draw. This is your notebook paper. Yours is portrait. Mine is landscape. But 4, and I'm going to put a graph in each one. I want you to do the first one. F of x is equal to, and I'm going to say 1/2 absolute value x minus 4 plus 2. And now what I want you to do is I want you to draw the parent graph. Draw the parent graph, or just dash it in. Parent, I want you to dash. And then I want you to sketch the actual graph that I put up here. This one, I want you to sketch it. Here, I want you to do the same thing, except here, I want you to do f of x is equal to negative 2 of x minus 1 to the 3rd power. That's supposed to be a 3 if you can see it. Minus 4. That's supposed to be a cube because when that thing raises up, it looks like something squiggly, but it's supposed to be a cube. So you sketch, I'll dash in. There's the parent graph. And I don't know why this thing goes crazy when I do dash lines, but every time I do a dash line, it does that at the end of it. Just beat me up, throw me in a van, and make me do that, okay? Because that's what they're doing. All right, over here, here's your parent graph. What did I?
Just the absolute value.
Is absolute value of your parent graph is? Didn't do it that time. There's your parent graph. All right, the next one. F of x is equal to 1/3 square root x plus 3 minus 1. So your parent graph here would be what? That line that goes to the right. F of x is equal to, and then this one, we're going to do the half a volcano. Let's do 3. Let's go -3. 1 over x plus, 1 over x plus 3 minus 1. And that parent graph is going to look like that. All right, take a minute and work on those. That means you too, Pendleton. Settle down, Pendleton. You're too loud. Y'all act like this in all y'all's classes, Pendleton? Is this the way y'all this rowdy in all your other classes?
Not really.
One person.
I have a funky English teacher, but I actually go to that class, and he likes you to interact with him. But here I kind of have to like scream at the microphone, so everybody in the room is like, ah.
So it's just not worth the extra work, is it? Of screaming. At least you don't have Slender Man for an English class. We have Slender Man here. Y'all got any of him for English? Y'all know who I'm talking about? There's an English teacher here that says it looks like Slender Man. I don't know. Who do you have for English? Is it on Polycom?
No, sir. I have, what's his name? Jeez. I think his name is Brett Johnson at the Easley campus.
So you have it. He does the video like I do.
No, sir. He's just a class, just a normal class.
Oh, so you go up to Easley?
Yes, sir.
Oh my gosh, why do you do that?
Well, it's actually a 45-minute drive to here to Pendleton from my house. Easley's only 20 minutes.
Okay, you should be going to the Easley campus and pipe in here.
I know, but the class was full. We were looking at it, and the class was full, but then I see that every time that it's only her there, and I'm like, well, maybe I should just go.
No, that's Oconee. That's Oconee campus.
Yeah.
There's nobody in the Easley campus. You need to get in there. I don't mind if you go over there. God, that'd save you a whole lot of time and money. Please do that.
I think I might. I don't know.
All you need to do is go over there and tell them that you want to attend my class in the Polycom room. There's nobody in there at this time. So all you have to do is just go in there and start the computer. Well, it probably already started, and I'll call you in just like I do now. You just need to let me know when you want to do that, and that'll save you a whole lot of gas and time and money.
Alrighty.
That means Pendleton won't talk to me because she's their spokesman. Do they pay you to talk? Is that what they do in Pendleton? The Pendleton class takes up a collection for you to talk? Or are you just a talker? Are you a social butterfly?
I'm a social butterfly.
Okay. Everybody else is introvert. What's today? 9 what? 9/5. And let me see what time it is because some of them are starting to fidget. So what time's class over?
11.
That figures. I'm always late. All right, Bays here. Crocker.
Here.
Platt.
Here.
Goolsby. Hagan.
Here.
Hawthorne. Do not leave yet. Cahaley.
Here.
Laney.
Here.
Darren. Aaron. And Dalton. Okay, this is Pendleton campus. Baker.
Here.
Batista.
Here.
Kane.
Here.
Jason. Herrero.
Here.
Lee Park.
Here.
Mincy.
Here.
Shuttleworth.
Here.
Stallworth.
Here.
Storm.
Here.
And Kennard.
Here.
And Miss Kerwin. And Miss Whiten is here.
Yep.
Okay. The only thing I want to tell y'all is, and this is with all the 110 class online as well as all the Polycom classes, continue to work on Chapter 1. And I don't know if I've opened up Chapter 2 or not. I mean Unit 2. But just keep on working on homework. And next week we'll go over some homework problems. I'm trying to get everybody up to one sheet of music. And I'm still doing kind of a review and kind of introducing new material at the same time. Eventually they'll both level out. And then we'll be ready to get on with Unit 2 or Unit 3 by then. All right, y'all have a good day. See y'all when? Monday. Have a good weekend. Go see The Nun. I'm going to go see it tonight. Or tomorrow night. See y'all.
Bye.